Cappers are automated machines which apply caps on bottles that have been filled with a factory product. Anything from shampoo to soft drinks. The closures the cappers apply include screw caps, push-down tops, and aluminum caps molded to the shape of the bottleneck. Cappers come in different sizes to meet the product manufacturer's packaging requirements. From 3-head machines that cap 40 bottles per minute to 36-head machines that cap 1,200 bottles per minute. Every capper is custom designed for the product being packaged, so producers must supply the capper manufacturer with samples of their specific bottles and caps. The first step of the design phase is to paint the samples white, so that engineers can scan them with a laser to produce a 3-dimensional computer model. Then the engineers use that virtual bottle and cap to design the machine's bottle handling equipment. This refers to the components which transport the bottles through the machine as opposed to the components that apply the cap. This computer-guided water jet cutter slices through a stainless steel plate to make the bases that support the bottle handling equipment on the capper from underneath. A computer-guided machining center shapes the complex bottle handling components out of stainless steel rods. The capper's bottle capping components are machined the same way. Every part undergoes a precision inspection. An engineer checks the dimensions with a device called a coordinate measuring machine. A computer-guided router cuts the plastic components of the bottle handling equipment from a 19mm thick sheet of polyethylene. Meanwhile, an electrician wires the capper's control panel. It houses the components which regulate the machine's speed, as well as the computer that controls all the machine's functions. The machine has sensors that detect the presence of a bottle and cap at the capping head. These sensors are wired to the computer. Other workers assemble the production line conveyor belt that ferries bottles into and out of the capper. The belt is comprised of plastic links connected with pins. To begin assembling the machine, workers attach the 3 capping heads to the overhead carousel. Then they install a capping chuck in each head. The chuck picks up a cap. Then the capping head rotates to screw the cap on the bottle. A computer-guided engraver labels the capper's in-feed star wheel, a disc with pockets that guide the bottles into the machine. Workers highlight the engraving with paint and inset a colored disc indicating the specific bottle size the star wheel is designed to run. They repeat these steps with the machine's 2 other star wheels, one in the center of the machine that moves the bottles under the capping heads, and another that transfers the bottles to the machine's exit. Workers manually assemble each star wheel. They verify the pocket size. Then, on the center star wheel only, bolt a stainless steel reinforcement layer and line the pockets with the rubber material that grips bottles. After installing the metal support bases on the capper, they mount the corresponding star wheels. The center star wheel and base have to be made in halves to fit around the machine's central shaft. Workers install the center guide. The bottles travel in the path between the wheels and the guide. Next, workers install a restraint belt made of the same rubber material that lines the center star wheel pockets. The belt and pocket prevent the bottle from spinning as the capping head screws on the cap. No capper leaves the factory without a test run. Before running the machine normally, workers run it at low speed to check that the components are properly aligned and the movements correctly timed. The in-feed star wheel receiving the bottles transfers them to the center star wheel under the capping heads. The capped bottles then transfer to the discharge star wheel, which guides them to the conveyor belt leading to the labeling machine.